Hey, what's up, fellas? Doing a video for Oscar tonight. He's building a sand dryer in New Zealand, and he's going to be using some extremely dirty waste oil. So we got to build a unit that will allow us to just throw some hot air into a very large area without worrying about spraying a little bit of that oil spray that's typical with some very dirty waste oils. Alright, fellas, so this video today is for Oscar, but Victory First brought up a question that was right on point that happened to be going on in the background. So he wants to know, how complete is the combustion when you're burning really hard to burn oils, like the really nasty stuff? When you have a firebox, you can combust it all when it's going into a foundry or anything that's hot. But let's say you're trying to build a sand dryer or some type of air heater that doesn't have a firebox that gets over 350 degrees. So how do you do that? Here's a little brainstorming I did. I had several different designs. I thought about maybe making a box setup where anything that can get those little particles to hit a hot piece of metal and further vaporize is what we want to do. So what I came up with is this one right here. So the gases come in through this way, pass by that plate, up under the plate, and out around this way. So there's a restriction plate in there that keeps the flames from just shooting in one side and out the other. So the flames would come in this way in this hole, swirl down around, and then creep up around the side and reconverge out the front.
Not only the destruction of our democracy and our
society. All right, so it took way too long to build this thing. Not all these parts you see here were cut out for this, but quite a bit of them were. It's, I think, 18 pieces total. So a little bit more elaborate than I wanted it to be, but nonetheless, I felt like this was the idea that could apply centrifugal separation into the equation as well. That's why the main reason that sealed the deal for me was that those little minute particles just aren't going to want to fly out of there as easily if we spin them 360 degrees before discharging them out the other end. So, not too much. I'm just kind of doing a quick little test version here. Nothing to write home about. I don't want to waste time on it being too fancy. I want to get this thing done tomorrow. I'm late already. I've been trying to do this for several days, but the weather has not permitted the test. And finally decided to give it a shot today. But that right there is the trick that solved the problem. How do I get a flame to go through this box, but not go through it? And this is pretty much what we got. It has to loop around 360 degrees before it can pass out the front there. So I think this will be close to being finished. But this is what we got. I think this thing's going to do great. You can see there how the flame goes down, comes out those two side ports there. And if the flame from the other direction hits that wall. And Kevin, this is for you, man. Just to kind of show you how easy this thing will light up. Once you get it set up anyway. It's really nothing to it when you ain't got no vacuum leaks in your line. And I was checking out your Teflon tape job. It looks like you might need to redo the Teflon on that brass piece that connects directly to the nipple and the nozzle end itself. So this is the test I did the other day for Kevin, showing him how to light this thing. And I decided to do a little splatter test on this particular burner. And as you can see, there's a little bit of residual there. And this comes from the gunk and the very cold stuff that's inside of the waste oil, like the antifreeze. The glycol doesn't burn at all and stuff like that. And just cold oil in general hasn't had time to heat up. You can see here, there's no noticeable splatter on this cardboard whatsoever. Versus this right here, within seconds, it's like you're using an airbrush gun to paint the thing. And now when you're spraying into a heat exchange or any firebox that gets over 400 degrees Fahrenheit, this isn't an issue at all. This won't even come up. But if you're trying to build a sand dryer that's just shooting hot air down a barrel that's say 3-4 foot diameter, that's unacceptable. So this is what would happen without this little vaporizer turret. I don't know what I'm going to name this thing yet, but just a quick little sample And you can see here it produces some splatter. I got to come up with a name for this thing. I thought about calling it a vaporizer or whatever, but I don't know for sure. We'll think about that. But here's another little, just a quick little whiff, and you've got some oil sample there. So you can see there is indeed an improvement. We'll slide it back, and I think I turned it up to full power here. Yes. Now I've turned the air up to maximum, and this thing's going to scream even hotter, and we're going to give it a go. See, I'm holding it to where the cardboard almost catches on fire. It literally gets to the point where it's about to burst into flames, and there's no noticeable splatter on there whatsoever. I do it one more time to where it almost turns the cardboard brown. It just started to turn it brown right there. You see that? That's not oil, that's the material about ready to burst into flames. This thing screams pretty hot. There's a little bit of improvement to be done. We need a shoehorn in the front there. But other than that, I think I like it. Definitely a good application for a sand dryer, or sometimes you just gotta heat sand up. If you're doing horse footing, for example. Oh man, set the wood on fire. Definitely a drastic improvement. We just need a little bit of a shoehorn action here on the flame intake, and this thing will be ready for hitting eBay. This would be best for sand drying applications, or any application where you don't have that firebox to give you that residual heat, or that ambient heat to vaporize that little bit of leftover stuff. We've seen videos where I've done testing where just having a firebox the size of even a 5-gallon bucket is enough to get rid of that minuscule spray that you're going to get from burning extremely difficult to combust fuels like axle oil and dirty waste oil from workshops that contains antifreeze and water and stuff like that. Sometimes even the windshield washer wiper fluid will end up in there. Any liquid that comes out of a car when they work on it ends up in those waste oil tanks. They don't separate it. For the amount of heat we saw, this thing held up fantastic. Phenomenal. Very impressed with the performance of this thing. I'm glad I didn't go with any of these other designs here. So at the end of the day, this little bad boy right here sealed the deal. And ironically, that's the last one I drew after I'd sat and thought about it. You know, all this other crap right here. This is just huge. This thing here, I couldn't figure out how to get the fire to come straight out of the front. That was the puzzling part to me. My brain couldn't figure it out the first day. And then it dawned on me. We're not necessarily dead just yet. So I managed to figure it out. I love it when that happens, when you're just stumped with a problem that just can't be had. And then all of a sudden, you're driving down the road or something, you ain't even thinking about it, and bam, there's the idea. That's why I keep a little notebook with me in my car. Actually, it's a notepad, and there's hundreds of drawings like this right there. Because that's usually when your brain comes up with the details you need to seal the deal. It's not when you're sitting in the shop. When it's the really hard ones. Like, I could not figure this out for nothing. That's how stupid I am sometimes. I know it looks great in hindsight, being 2020 and all, but yeah. All right, fellas. There's a couple of interesting things to look at here in this particular section of the test. You're basically probably just going to sit here and listen to me ramble for the next 3 minutes, but there are some pretty cool things that happen coming up here. I do a couple flame out tests where I turn the burner on and off really fast, which is kind of cool looking. It's neat how quickly it lights back up, but I also wanted to put this on here for Kevin, who's struggling to get his burner lit. I wanted to show him what it actually looks like from start. Sometimes there is a bit of a situation, and until you get all the air bubbles primed out of that line, things won't be normal. But typically once you get the burner established, it lights like a candle every time. There's no special event where sometimes it works and sometimes it don't. It's all you have going on is you're getting a vacuum leak, brother. I can tell by the Teflon tape job on the brass section that connects to the nozzle that you're possibly getting a leak there still, and I can see it from the way the oil splattered out on yours, how we're getting that intermittent sputtering. It should be a continuous flow of oil, and there is a small section of video in this test that shows that constant spray. So here I'm just kind of messing around with this thing, trying to find out where it likes to live without too much back pressure. I knew we would need a standoff. I'm a little disappointed in the actual size of the intake. I drew this thing on a computer and didn't have a really good reference scale. I used a drawing of one of my cutouts for a particular burner that I sell, and it didn't do so good. So I'm a bit disappointed, but this one would work great with my micro silicon carbide combustor. This thing gets so hot, it's insane. It would make a great sand dryer component, Oscar. So that's what this video is all about. I just wanted to show this to you. And this here is kind of for Kevin, again, just showing him how easy it is to light this thing up when everything's where it's got to be. There's really, you just got to get the air turned on low. See how we got a whole big lazy flame coming out the front? That means we had plenty of fuel, but not enough air. And what you're getting is the opposite. You're getting no fuel, so it's not lighting at all. So that's what happens when you're getting too much. And when you're not getting enough, it just doesn't light. So that's what we got. And here I am just cycling an on-off. Just kind of messing around with it while we're done with the test here. But nonetheless, fellas, we're going to pick this up in the morning when we got some daylight. And I'm going to take a better look at this thing. I might put a micro silicon carbide nozzle on here since it's smaller. But total success in my eyes here.